This conference will now be recorded.
Guys, a moment. Okay, because I need to repeat what I have said till now. Okay, in the previous class, you have designed 3 circuits. They are a basic LED circuit and then 5 volts charger circuit, then a simple fire alarm circuit. Okay, now we are going to design circuits related to ICs. Okay, and in ICs, first of all, we are using 555 timer. Okay, as I have already told you, we are dealing with circuits related to multivibrators. Okay, and many of you know what is a multivibrator is. Okay, the output will be absorbed in waveforms if you consider the theoretical part. Okay, but when you need to observe the output in the simulator, we need to use a LED at the output pin of your 555 timer. Okay, and all of you know what is a stable multivibrator, bistable multivibrator, and monostable multivibrator. Okay, now we will going to design the stable multivibrator circuit, and we will simulate the circuit and observe the output. Okay, just I will be so quick that we can cover more circuits today, and we have to go to PCB Wizard software also. We need to start designing the PCB layouts from today onwards. Okay, take all these components from the gallery. Okay, I will take them again. Just wait a minute. From the power supplies, take a 9 volts battery, and from the passive components, you need to take 3 resistors. Okay, after taking 3 resistors, you need to take an electrolytic capacitor. Okay, and from the and from integrated circuits, you need IC, right? Okay, take the 555 IC, and at last you need an output LED. Okay, for that go to output components, scroll down and take an LED. Circuit. Okay, now I will give the connections quickly. If you want to rotate the component, just select the component and click on Ctrl+R. Okay, place the components like this and connections as I have given. Okay, you need to connect the pin connections like this. Okay, connect pin number 1 to ground, and your pin numbers 2 and 6 will be shorted. They should be connected to the bottom side of. Okay, and 7th pin is connected in between R1 and R2. Okay, and IC will be connected to power supply. Okay, and you know already the output from the 555 timer is taken from third pin. Okay, third pin of the IC will be output pin. Okay, my connections are completed. Now I just need to change the values. Okay, R1 you can keep it as 10 kilo ohm and R2 as 150 kilo ohm. Okay, as I have already told you in the previous class, these are some previously designed circuits, and if we give those values correctly, then we can output perfectly. Okay, okay, my values are also completed. You need to use a 10 microfarad capacitor and a 470 ohm resistor at R3 pin. Nothing but at the output, a 470 ohm resistor is enough. Now I am simulating the circuit. Okay, you can observe that the LED turns on and off. Okay, nothing but when it comes to a stable multivibrator circuit, the output will be varying from one state to another state. Okay, if you consider a a rectangular wave or square wave, you can clearly observe that we will have positive cycle and negative cycle, but on and off. Okay, like okay, you can consider the LED output. Okay, if it is completed, let me know. I will give you 2 minutes. After that, we will be designing another circuit. Okay, just be so quick that you can cover more circuits. Okay, you are fast enough, we can cover more circuits. Complete it quickly, and if it is finished, just let me know. Okay, after 2 minutes, I will change the circuit. If you have any queries, you can ask me.
Can I ask you a question? Hello?
Okay, Mr. Srinivas, what is your doubt?
Where is the ground connection?
Okay, there is no need of any ground because battery terminals can be considered as positive and negative. Okay, the battery negative terminal can be considered as negative, and there is no need for using ground.
But you are because the connection.
Okay, your voice is disturbing.
Thank you so
Can you
much.
type in your doubt?
Oh, thank you. Okay, my doubt is clear.
The circuit name is a stable multivibrator circuit. Okay, by using 555 timer IC. Okay, if it is completed, save the circuit. Then we can go for another circuit. Okay, just make it fast. Okay, did everyone got? Okay, you have any doubts, you can ask me. Now we will going to design next circuit. Okay, this circuit is a stable multivibrator. Okay, the next circuit is bistable multivibrator, because by making simple changes to this circuit, it can be converted as a bistable multivibrator circuit where will be two stable states. Okay, just you just need another resistor and an LED. Okay, by making simple changes. Okay, like you need to add another resistor at the bottom and you need to remove the third pin resistor, connect it at the bottom, just directly connect the third pin at the junction anode and cathode terminals. Okay, okay, now you need to change the resistor R1 value also. Okay, just change it to 2.2 kilo ohms. Okay, okay, now run the circuit. You can clearly observe that the LEDs alternately turn operation of a stable multivibrator circuit. Okay, make it fast if it is complete. Okay, forget to save the circuits. Okay, I will give you 2 minutes. After 2 minutes, we will go for another circuit. Okay, if you have any doubts, just ask in the chat box or you can turn on your mic and ask. Okay, just 2 minutes, complete the circuit and save it in your system. Guys, please respond in the chat box. Is it completed or not? Completed only for one. Okay, I'm moving on to the next. In case if you haven't completed the circuit, okay, just take a screenshot of the and complete it when you are free. Okay. The next circuit name is speed and rotation of this motor by using 555 timer. Okay. Speed and rotation control of a DC motor. Okay, open the gallery and take the components. Okay, you need a motor which will be in output components. Okay, and in discrete conductors, take 3 diodes. Okay, after that, you need 2 resistors in the circuit. You just directly copy and paste the course directly available to you. Next, you from the discrete semiconductors take an NPN transistor. Okay, and from the input components, you need to take a DP/DT switch. Okay, we need a switch for changing the rotation. Okay, these are the components which are required. Okay, now I will design the circuit as quickly as possible. Okay, one more component I forgot to tell you. We need a potentiometer in the circuit, which will be okay. These are the components. Respond quickly. Can you find? Can you observe my screen or not? Okay, just hang on a minute. Guys, is it clear for everyone? Can you observe my screen? Please respond quickly. Okay, thank you. Okay, these are the components that you need to select from the gallery. Okay, from the gallery, take a potentiometer. You need to take 3 diodes, and from the input components, you need to select a DPDT switch. Okay, and then now you need to select 555 timer. Okay, and from discrete semiconductors, take a NPN transistor. Okay, now I am giving the connections. Just take all the. Okay, you can observe that in DPDT switch, the last 2 terminals will be shorted and the middle 2 terminals will be shorted. Okay, give the connections properly. Okay, my circuit is completed. Sorry, I have to give the connections on the right side. Okay, now I am running the circuit. Okay, you can observe that the motor is rotating on forward direction. Okay, and by varying the potentiometer, you can change the speed of the motor. Okay, the speed can be increased and decreased by using the potentiometer knob. Okay, after that, for changing the direction, okay, we need to change the direction of motor, right? For that, you need to click on the DPDT switch. Okay, you can observe the dotted lines, right, in the center of DPDT switch. If you give a click at that position, it will change the DPDT switch pole connections. Okay, that means now you can observe that the motor is rotating in reverse direction. Okay, you can observe the emulator is rotating, right? If you click on the center of the switch, it will change the directions. Okay, and when you change the potentiometer value, the speed can be increased and decreased. Okay, according to your requirement. Okay, I will give you 3 minutes. Just complete the circuit. I will give you another circuit. Okay, if it is completed, let me know. quickly respond in the chat box. Okay, completed for one person. Okay, Mr. Tarun, you can get the diode from discrete semiconductors. Okay, open the discrete semiconductors folder and you can find the diodes and transistors from this folder. Okay. Okay, make it fast. In 2 minutes, I will be giving you another circuit. Okay, we will go for next circuit. I have given you enough time. The next circuit name is a simple. Okay, we will design panic alarm circuit by using 555 timer. Just stop the simulation. Okay, save the circuits, guys. Don't forget to save your circuit. Okay, circuit name is a simple panic alarm by using 555 timer. Okay, from the output components, take a buzzer. And from input components, you need a button. Guys, is it not audible for everyone? Please respond quickly. Okay, it is your internet connection, Mr. Venkat Reddy. Check your internet connection. Okay, these are the components needed for panic alarm circuit. Just give the connections properly. Okay, the connections are completed. Just need to change the values of some resistors in capacitor. Okay, just 10 microfarad capacitors are enough. Okay, I will give you 1 or 2 circuits more. Then we will go for designing the PCB layouts for these circuits. Okay, the connections are completed. Now I'm running the circuit, and when you click the button, you can observe that your buzzer starts ringing. Okay, this is simple panic alarm circuit by using 555 timer. Okay, just when you push the button, you can clearly observe the buzzer starts ringing. Okay. Okay, if it is completed, let me know. We will go for another circuit. Okay, I will give just 1 or 2 circuits. After that, we will be going to design the PCB layouts. Okay, 1% completed. Okay, guys. The next circuit name is LED flasher circuit by using IC 555 timer and IC 4017B decade counter. Okay, the next circuit name is LED flasher. Okay, for that, just you need to make small changes in the circuit. After that, we will take the components. Open the gallery. Okay, there is no need of capacitor in the fifth pin for LED flasher circuit. Okay, now go to gallery, and from ICs, okay, we need to take the 4017B IC. Okay, in integrated circuits, we will have two subfolders. Okay, they are 7400 series and 4000B series. Okay, just open the 4000B series, and if you scroll down, you can observe the series number. We need IC4017B. Okay, here it is. Okay, which is a decade counter. Select it and place it on the workspace. Okay, and for LED flasher circuit, we need 10 LEDs. Okay, for that, go to output components, take an LED. We need to connect 10 LEDs to the decade counter. Okay, you need to take 10 LEDs, and from 0 to 9, connect all the 10 LEDs. Okay, guys, connect the 10 LEDs like that. After that, okay, just take another resistor. Okay, connect all the cathode terminals. And now connect the resistor other end to the ground. Okay, now connect the enable and clock pin of IC4017B to the ground. Okay, you can leave out the 10th pin. Don't bother about it. Now the output of 555 timer IC should be connected to the clock input of 4017B. Okay, my connections are completed. Now I need to change some values. R1 1 kilo ohm resistor is enough, and then R2 should be 47 kilo ohms. Okay, now the capacitor value should be as low as possible. Okay, we can increase and decrease the speed of flashing by changing the capacitor value. Okay, my connections are completed. Now I'm running the circuit. The base resistor, you can change it to 40 ohms. Okay, now I'm running the circuit. Okay, you can observe that the LEDs get flashed right. Okay, from top to bottom, one by one, the LEDs will flash. Okay, now I forgot to tell you about changing the colors of LEDs, right? Just stop the simulation and give a right click on the LED for changing the colors. Okay, and if you give a right click, you will find models, right? In models, you can change the colors of LEDs. Okay, the first one is red. I am changing the colors. The second one will be yellow. Third one green. Okay, like that you can change the colors also. Okay, now I am running the circuit. Okay, you can clearly observe the colors of LEDs are changed. This is my screen updating. Output, please respond quickly. Can you observe the output? Guys, is it updating now? Okay, complete the circuit quickly. I will give you one more circuit. After that, we will be working with PCB Wizard software. Okay, complete it and respond in the chat box. Okay, the circuit name is LED flasher by using 555 timer and IC4017B decade counter. Okay, just mention as LED flasher. That is enough. Okay, only completed for 2. Guys, please be quick. Okay, guys, the next circuit name is a simple battery level indicator. Okay, there is no need of 555 timer in this circuit. Okay, take a power supply and then go to ICs. And we need LM3914 IC for battery level indicator. Okay, that can be directly available in the integrated circuits. Okay, just scroll it down and take, which is named as dot bar display driver. Okay. In integrated circuits, just scroll down and take this IC. Okay, in this circuit also we need 10 LEDs. Just take 10 LEDs from the output components. Guys, is my screen updating? Guys, is it updated now? Okay, I think it is updated. Okay, from the gallery, from passive components, you need to take some resistors and potentiometer. Take 3 resistors. And a potentiometer. Okay. Now take a switch from the input components. Okay, after that, take the LEDs. Okay, guys, I have some network issues. So if my screen is not updating, please let me know in the chat box. Okay. I think you have the ICs, right? LM3914. After that, take 10 LEDs and connect them to pin number from 1 to 10. Okay. Just listen to my. If I finish, so just follow instruction. Connect 10 LEDs to the pin numbers to 10. Okay. Okay, just connect the 10 LEDs like that. Give the connections quickly. Okay, those are the connections, guys. Guys, is it audible or not? Those are the connections. The circuit name is a simple battery level indicator. Okay, if your connections are completed, I will just change some values of components. Okay, the resistors R1 is 18 kilo ohms. Next, R2 is 4.7 kilo ohms. Okay, R3 will be 56 kilo ohms. Okay, those are the connections are completed. Now, if you run the circuit and change the potentiometer levels, okay, a simple battery level indicator. Okay, I will run the circuit. Now, if I change the potentiometer values, okay, wait a minute, you need to close the switch after simulating your circuit. Now, if you change the potentiometer value, you can observe the levels. Okay. And if you want to change the colors of LEDs, just go to the LEDs and you can directly change the models of LEDs. Okay. Okay, the circuit is completed. Okay, if it is completed, let me know. We will start the PCB wizard soft production today. Okay, just be quick. If it is completed, let me know. Okay, guys. Is my voice audible? Please respond. Please respond in the chat box. Okay, thank you. Now all of you minimize the liveware software and open PCB wizard software. Okay. If you open the PCB wizard software, it will look similar to liveware, but it is not same. Okay, just open the PCB wizard software. Okay, guys. Okay, now come to the options which are available at the left top side. Okay, which are similar to all the windows like file, edit, view, insert, tools, windows. Okay, help. These are all similar to every window that we open. Okay, now come to the left side options which are available. Okay, normal, real world, artwork, up. Okay, unpopulated. Okay, all these are different types of our layout. Okay, when you completed designing your PCB layout of any circuit, okay, then if you want to check the real world circuit, nothing but మీరు డిజైన్ చేసిన సర్క్యూట్ ని రియల్ వరల్డ్ లో ఎలా ఉంటుందో చూడాలి అనుకుంటే ఈ రియల్ వరల్డ్ అనే ఆప్షన్ ని క్లిక్ చేస్తారు. నెక్స్ట్ ఆర్ట్ వర్క్ అంటే మనం ప్రింట్ తీసేది ఎప్పుడు ఆర్ట్ వర్క్ అనమాట. ఓకే, యూ విల్ నో ద డిఫరెన్స్ ఆఫ్టర్ డిజైనింగ్ ది సర్క్యూట్. ఓకే, now come to the shortcuts which are available for you. These four options are similar to liveware. Okay, మనకి select tool గానీ pan tool గానీ zoom tool and delete tool, these are similar to liveware. And now we have some additional options, okay, which are used for designing the PCB layouts. Okay, the first one is track. Okay, track is nothing but electrical connection between two terminals. Okay, in liveware we use wire. Okay, but here it is not wire, we call it as track. Okay, next the second one is pad. Okay, it is used in rare cases. Okay, I will explain you how to use a pad in coming classes. Okay, the next one is board area. Nothing but after completion of our layout designing, we need to give a particular sizes to our board. Okay, that size is given by the board area. Okay, which is in green color here. Okay, I think my screen is updating and everything is fine, right? Please respond my voice and my screen. Okay, thank you, Miss Susmita. Okay, guys, and the next one, the red color, this one is called as copper area. Okay, after completion of your layout and giving the board area is nothing but how much size of the board that we need. Okay, again copper area is nothing but we need to provide the copper area, how much copper area is needed for our circuit. Okay, so that the excess copper area will be removed in etching process. Okay, the last one is copper label. Okay, if you place the cursor over it, it will give you the names of it. Okay, that AA is called as the copper label. Okay, sometimes if you want to put your names on your PCB board, okay, then you can add your names to your PCB. Okay, now I will design a basic circuit. Okay, now open the gallery. Okay, here you can observe the PCB component gallery. Okay, I have already explained you the difference between a circuit symbol and a footprint. Okay, now come observe these symbols. Okay, these are not circuit symbols of components. These are called as footprints of components. Okay, suppose if you consider a resistor. Okay, here are the some footprints of resistors with sizes, because in practical we use the resistors which are required in our board, right? So selecting the size also is mandatory in some circuits. Okay, now there is no need for us to take the sizes, because we can select and use any one of the resistor footprint. Okay, suppose if you want to take a 0.3 inches resistor, just give a click on it and place it on the workspace. Okay, I will zoom in a little. Okay, this is the footprint of a resistor. Okay, footprints are nothing but practical component images or symbols. Okay, now if you keep it in real world, you can observe a practical component. Okay, is that clear for everyone? Please respond. Did you get my point that what is the difference between a footprint and a circuit symbol? Okay, thank you, Mr. Srinivas. Now again, keep it in normal. Okay, these are the footprints of components, not the circuit symbols. And suppose if you want a IC, okay, in previous learned circuits, there is a 555 timer, right? How many pins does a 555 timer have? Can anyone tell me? How many pins do a 555 timer have? Okay, 8 pins, right? Okay, thank you. Here, when it comes to the integrated circuit footprints, okay, these are not the circuit symbols. For 555 timer, you need to take a 8-pin dual inline IC. Okay, if you take it and place it on the workspace, the footprint of a 8-pin IC will look like this. Okay, don't confuse when you are designing the circuits. Okay, when you open your circuits, your circuit symbol will be different from your footprint. Okay, don't confuse over it. And to identify the pins of an IC, from the notch left side begins the first pin. Okay, and if you place the cursor over the pins, it will give you the identification of the pin. Okay, pin 1 of IC1, like that, pin 2 of IC2, pin 3 of IC3, like that. Okay, from notch left side begins the first pin and right side will be the last pin of your IC. Okay, nothing but 1, 2, 3, 4 and 5, 6, 7, 8. Okay, like that you need to distinguish between circuit symbol and component footprint. Okay, now I will design. What is the first circuit that you learned in Livewire? A simple LED circuit, right? A basic LED circuit. Okay, for that you need. Okay, now come to the power supplies. Okay, for power supplies there will be only a terminal block which is used for providing the electrical connection. Okay, whether it is AC or DC, always you need to use a terminal block only. Okay, you will know what is a terminal block is when our circuit is designed and completed. Okay, just for power supplies you need to take a terminal block. Okay, one more thing I forgot to tell you. In workspace, you can clearly observe plus signs, right? Okay, in the screen, you can observe these plus lines, right? From one plus to another plus, and this is a 1-inch square box, guys. While designing these PCBs, size is a major factor because we have to try the maximum possible ways to reduce the size of a PCB. Okay, for example, in olden days, we used to use mobile chargers of 3 or 4 inches, right? Okay, for Nokia mobiles, they need to use 3-inch mobile chargers. Okay, the size is very big. Okay, but nowadays, if you observe a Apple iPhone charger, okay, its size is only 1.5 inches. Okay, that is the difference. Okay, the working is same. Okay, the working function is same for both the chargers, but the inbuilt circuitry is changed. Okay, the sizes may affect your design. Okay, that is the reason while designing PCBs, the size must be as minimum as possible. Okay, this is a 1-inch square box. If you clearly observe the plus signs. Okay, I have taken a terminal block for giving the power supply, and I have taken a resistor. Okay, don't bother about the component values because for footprints there will not be any need for giving the values. Okay, because footprints cannot alter any one of our circuits because we can place the components after designing the PCB board. Okay, while placing the components we can give the correct value. Okay, so that there will not be any mistakes in our circuit. Okay, while designing the layout there will be no problem if you don't use the values of components. Okay, what is the next component? LED, right? Here LEDs are directly provided like 3mm LEDs and 5mm LEDs. Okay, while designing circuits always use the 5mm LEDs which are standard, because if you use the 3mm LEDs you may get confused with the connections. Okay, now I have opened the 5mm LEDs folder. Here you can directly observe the colors, right? Okay, these are the footprints. Okay, all are 0.2 inches LEDs, and you can select the LED based on colors. Okay, you can select any one of the LED. Okay, these are the 3 components which are required for the basic circuit, right? I will just close the gallery. Okay, now observe, this is a terminal block. Okay, nothing but we can place any supply, either it is AC or DC. If it is a DC, we can directly connect 2 battery wires to this terminal block, and from the terminal block we can take the supply. Okay, now you can place the components as you like. Okay, there is no need to follow my design. Just try to reduce the size of your layout. Okay, now you are not designing any circuits. This is the PCB layout that you are designing. You can place the components as you like. Okay, and here in LED, okay, this is the footprint of LED, right? For LEDs there will be a plus sign for the anode terminal. Okay, the remaining terminal will be your cathode. Okay, now what are the connections in basic circuit? I will just go to liveware. Okay, for basic LED circuit there is only need of 3 components. They are a battery, LED and a resistor, right? Okay, these are the 3 components which are needed. Okay, from the battery positive terminal we need to connect it to the resistor, and from the resistor other terminal we can connect it to the LED anode. Okay, this is the basic circuit, right? This is the circuit that I am designing the layout PCB now. Okay, now open the PCB wizard. These are the three components. Okay, from where to where I need to give the track? Can anyone tell me? From which point to which point I need to give the track? Can anyone tell me? Please respond quickly. Okay, if you understand the circuit, you can easily design the layout. Okay, or else you may get confused. Okay, now observe, from the battery positive terminal, we need to connect it to the resistor, right? Okay, these are called the pads of components. Okay, in footprints, there will be only pads. Okay, pads are nothing but the points where we solder the terminals. Okay, now select the track which is present at the top side. To the right side of delete option, you will observe a track symbol. Just click on it. You will observe a green plus signs. Now you need to click on the center of the pad for establishing a connection. Okay, you need to click on center of the pads. Okay, just give a click and again give a click at whatever the position you want to take the direction. Okay, now the connection is completed, but still you can observe the line is not ended. Okay, for ending the track, you need to give a right click on your mouse. Okay, just 2 times give a right click on your mouse and then give a left click so that the track will disappear. Okay, again I am clicking on the track. Okay, you can observe a green line from the resistor other terminal to LED anode. Okay, like that I have connected, but you can observe that the track is not escaping. Okay, not completed. Then you need to give 2 times click on the right side. Okay, again give a left click so that it will come to normal. Okay, now my 2 connections are completed. Okay, if you observe the circuit from the battery positive terminal to resistor and from resistor to anode and from cathode to battery negative. Okay, what is the other connection remaining? From battery negative to cathode. Okay, that is the last track, right? Just click on the track. You can directly connect the 2 pads. Okay, now my connections are completed. Okay, now I need to explain you another point. While designing PCBs, okay, there should not be any 90-degree angles. Okay, here is a 90-degree angle, right? Nothing but, okay, I will explain it. There should not be any 90-degree angles in your tracks. Okay, because there will be a loss at the etching process. Okay, I will post the theory related to this. Okay, but make sure that there is no 90-degree angle in your layout. Okay, for simple circuits you can easily design the layout, but for large circuits you may use a 90-degree angle. Okay, that is not recommended. Okay, so you never. Okay, Mr. Pawan Kalyan says that my voice is not clear. Okay, can anyone confirm? Is my voice is not audible for everyone? Okay, just make sure that there is no 90-degree angle in your layout. Okay, PCB layout. Okay, I have given the tracks, right? I will repeat it again with another circuit. Don't bother about it. These are the routing. Okay, I have routed the circuit. Routing is nothing but giving the track, okay, to the pads of each and every component. Okay, my circuit is completed, right? My routing process is completed. Okay, but I have told you that there should not be any 90-degree angle, so I am removing it and I will reroute it. Okay, just click on the pad. Just you can bend your tracks like that. Okay, without using 90-degree angles, you can just bend your tracks. Okay, whenever you need to bend your tracks. Okay, now after routing, the next step is to give the board area to your PCB layout. Okay, now for that, click on the circuit board, nothing but the green color square box or rectangular box. Click on it and drag it from a point where all the components should be inside of your circuit board. Okay, click on the circuit board and give a left click on your mouse and drag it to a position where all your components should be inside. Okay, that means suppose if you just wait a moment. Okay, suppose if you give the board area like this, okay, that is not correct. Okay, your board area should not be touching any one of the footprint. Okay, your all the component footprint should be inside of your board area. Okay, nothing but you are specifying some size to your PCB board, right? Okay, someone asked me to repeat the process. Okay, Mr. Tarun, I will repeat it with another example. Don't bother about it. Okay, I am just explaining it for your understanding. Okay, I will explain it by reducing the size of this circuit. Okay, so that you can understand clearly. Okay, you need to give the board area like that. All the footprints should be inside of your board area. Okay, again the next step is to give the copper area. Okay, select the copper area and drag it similar to the board area. Okay, now the copper area is placed. Okay, copper area and board area or circuit board area can be same. Okay, nothing but I will just show you. Now I have removed the copper area from the board. The board area is different and the copper area is different. Okay, they can be same in lengths and breadths. Okay, that is nothing but they can be same, or else you can use the board area greater than copper area. Okay, I will just increase the board area. Wait a minute. Okay, now if you observe, all the components are inside of my copper area and you can give greater board area than the copper area. Okay, or they can be similar. Okay, or same. You can use the same board area and copper area, or you can use a greater circuit board area than the copper area. Okay, is it clear till now for everyone? I will design this. Okay, one more point is there. After completion of this, okay, after giving the board area and copper area, you can give names to your circuit board. Okay, nothing but if you want any labels or names in your PCB board, then you can give names. For that, just click on the copper label and click on a location where there is no footprint is available. Okay, if you give a click, it will open a text window. Okay, now give the text whatever you want. Okay, I have named it as basic because this is the basic circuit, right? I have given a label as basic. Okay, it will be in reverse direction only because whenever it is printed on to the PCB board, okay, then it will be looking as normal. Okay, then it will appear as normal direction. Okay, for now, when you are designing, it will be in reverse direction only. Don't bother about it. Okay, this is how your PCB layout is prepared. Okay, did you understand, everyone? Now, as I have told you about size, I will repeat the same circuit by reducing the size a little bit. Okay, now take all the components. Okay, I am repeating the process, entire process. Just wait a minute. Okay, again take all the components. Always select the PCB components, not the circuit symbols. Take a LED. From the power supplies, take a terminal block. And from the resistors, take a 0.3 inch resistor. Okay, you can take any one of the resistor you want. Okay, now always try to reduce the sizes, right? I will keep the battery here. Okay, whenever you are designing the layout, one more instruction you need to follow is one footprint should not be overlapped with another footprint like this. Okay, because minimum spacing between the component footprints must be used. Okay, here you can observe that the resistor and battery terminal are placed at a minimum distance. Okay, there is no problem here, but in case if you place a component like this, okay, that is not the correct way because the footprint should not get overlapped. Okay, I will show it in real world. You can clearly understand. Okay, this is how your real world circuit looks like. Okay, guys, if you clearly observe, this is a terminal block with screws where you need to place the wires from battery and tighten the screws. And here is the resistor, and from the resistor, this is a LED. Okay, from LED cathode, it is directly connected to the terminal block. And I have given the label as basic, right? Now, observe it here. I have placed a terminal block and placed a resistor on top of the terminal block. Is it possible for us to solder the terminals like this? Please respond. Is it possible for us to solder the terminals like this? Not possible, right? There should be minimum spacing between the component footprints. Okay. If you place the component like this, then there is a possibility for soldering the terminals. But in case if you overlap the footprints, there will not be any possibility for you to. Okay, if you place the two components like this, there will not be any possibility for you to solder the terminals. Okay, that will be a error in your PCB layout. Okay, I am changing it into normal. Okay, now I have placed the resistor like this, and okay, the LED also should not be overlapped. Okay, no component should be touching other component footprints. Okay, make sure that there is minimum spacing between your components. Okay, I will try to reduce the size of the circuit. Okay, I just placed the components like this, and now I will click on track. Directly connect from battery positive to resistor, and then from resistor to LED anode, and from cathode to battery negative terminal. Okay, my routing is completed for this circuit. Now I need to give the board area. Okay, for that click on the green color rectangular board which is available at the top side. Just place all the components inside of your board area, and again give the copper area also. Your board area and copper area can be similar. Now if you want to give any labels, you can give labels. Okay, now if you observe, both are similar circuits, right? But if you observe, the sizes are different. Okay, this is the same circuit with same components, and this is also the same circuit. But if you observe this size, okay, I will just place it in a square box. Okay, now observe from here to here in a plus. Okay, I told you we can measure the sizes, right? This is a complete 1-inch square. Okay, like 1.9 into 1.9, think like that. If you observe this, this is a simple reduced size circuit. Okay, both are similar, but the size is different. Okay, is it clear for everyone? While designing PCB layouts, size is a major factor. You should always try to reduce the size of your PCB. Okay, now check it in real world. This is how your real world circuits look like. Okay, both are similar, but the sizes are different. Okay, now I told you that artwork is what we take the printout from the printer, right? Now keep it in artwork. If you observe, artwork is nothing but only the tracks are available for us. Okay, that entire black area is called as copper area. Okay, in artwork, the entire black what you are looking is called as the copper area. Okay, the remaining white area will be etched off. Nothing but the white area which you are looking at will be removed in etching process. Okay, is that clear for everyone? Please respond in the chat box quickly. Okay, thank you. Do we have time? Okay, it's 5:42. I will design another circuit. Okay, just change it to normal, and if you are okay, you can delete it. We will design another circuit. Okay, now we will design. What is the next circuit? 5 volts charger, right? Okay, I will just give the components of 5 volt charger. You try to design the layout for that circuit, and if it is completed, post a picture in WhatsApp group. Okay, I will check the circuits which are placed in WhatsApp group, and if there are any mistakes or connections, I will verify it and I will tell you the mistakes. Okay, if any mistakes are present. Okay, I will just give the components required for the 5V charger now. Okay, that is a task for you. Now take the components which are necessary. Okay, for power supply, always for AC or DC we need a terminal block. And what is the next? Transformer, right? For transformer there will not be any footprint available for you in PCB wizard. Okay, because transformers are direct components, they need to be wide. Okay, by using terminal blocks only we can connect transformer primary winding terminals and secondary winding terminals. So okay, for transformer take connectors of 2 pins. Okay, in connectors take single inline connectors of 2 pins. Okay, just take two 2-pin connectors for transformer. Okay, these are two 2-pin connectors which are used as primary and secondary windings of your transformer. Okay, and for regulator also there will not be any footprint. For that take a 3-pin connector. Okay, in 5V charger circuit you need to use 3 connectors for transformer as well as regulator. Okay, there will not be any special footprints for those 2 components. Okay, just keep it aside. Okay, now what is the next component needed? Bridge rectifier, right? For that go to discrete semiconductor and you will find a bridge rectifier. Okay, just take a bridge rectifier from the discrete semiconductors. Okay, the next step is filtering, right? For filtering take a ceramic capacitor or electrolytic capacitor, whatever it may be. The footprints can be taken as you like. Okay, I will take a capacitor. And what is the next step? You can use a 3-pin connector, right, for regulator. Okay, after regulator just we will take the output from a resistor. Okay, these are the components which are required for 5V charger. Okay, now I need all of you to design the layout PCB for this. Okay, try to reduce the size of your PCB as much as possible. Okay, you can place the components wherever you like. Okay, in you can place the components as you like. Okay, no need to follow my design. Okay, just place the components as you like, but make sure that all the routing is in order. Okay, there should not be any wrong connections. Just make sure to connect the circuit in a proper way. Okay, this is the task for you. Okay, these are the components. Just take a picture if you are confused with the footprints. Okay, don't design large circuits. Okay, try to reduce the size as much as possible. Okay, if you place the components like this, the size will be more because the order is like this. Okay, if you place the components like this, you can find that it is exceeding more than 2 inches. Okay, from here to here 1 inch and here to here another inch. Okay, like that. Don't place the components like this. You can change the places of footprints. Okay, change the places of footprints and design the layout PCB. Okay, after that you can give labels. You need to add the copper area and you need to add the board area. Okay, at last give a label to your circuits as 5V charger. Okay, keep it in normal volt and you need to place 2 pictures if it is completed. Okay, take a picture of the normal design and then place a picture of your real world design also. Okay, is it clear for everyone? I will design another simple circuit and I will close it for today, and tomorrow we will design number of circuits. Okay, is it clear for everyone? Please respond in the chat box. Quickly guys, there is no much time. Okay, thank you. Okay, now the next circuit is simple fire alarm, right? Okay, I will design the simple fire alarm circuit layout and then we will close it for today. Okay, tomorrow we will design the circuits related to ICs. Okay, because while designing the PCB layouts of ICs, you may get confused easily because you may not identify the pins correctly and you may give wrong connections. Okay, while routing there should not be any short circuits because one track should not be overlapped with another track and one component footprint should not be overlapped with another footprint. Okay, now I am removing the components for 5 volts charger and I will take the components for simple fire alarm. Okay, you need two resistors in this circuit and a capacitor, right? After that you need a diode and a transistor, NPN transistor. Okay, in discrete semiconductors, if you scroll down, you can take any one of the footprint. Okay, because footprint is similar for either NPN or PNP transistor. Okay, you can take the footprint as you like. Okay, next from the output components, take a buzzer. Okay, which is used for alarm. And now we need a thermistor, right? Okay, a temperature sensor which is used for detecting the fire or heat. Okay, for that go to input components and from input components go to sensors and in sensors you will find a thermistor. Okay, this is a thermistor footprint. Okay, that is not a capacitor. Take a thermistor footprint. Now place the components. Okay, can anyone tell me how to identify the pins of this transistor? How to identify the pins of this transistor? Please respond quickly. How to identify the pins of a transistor? No one knows. Nobody is there to answer. Guys, is my voice audible? Okay, you are wasting my time. Okay, I will explain it. From the notch begins the emitter. Okay, emitter, base and collector. Okay, which is closer to the notch will be considered as emitter terminal of your transistor. Okay, now place the components because you have already designed the live wire circuit diagram of a simple fire alarm. Okay, now I need all of you to design the PCB layout for that circuit. Okay, try to reduce the size as much as possible. Okay, and one more point, if you are okay with the footprints, you can delete the labels of your footprints. Okay, if they are clumsy and you are confused, you can delete the labels of your footprints. Okay, nothing but names of your component footprints. Okay, now arrange the components as you wish. Okay, just make sure that size is small. Okay, you should always try to reduce the size of your PCB. Okay, I just placed my components like this. Okay, you can place your own design. Okay, don't follow my design. Just try your own designs. Okay, don't overlap any component footprints and never use a 90-degree angle in your circuits. Okay, and one more point, you can use the bottom space of components. Suppose, okay, I will keep it in real world. Okay, suppose consider it as a terminal block, right? The middle space or the bottom space will be empty, right? Okay, and in buzzer also the bottom space will be empty. Okay, you can use that space also for taking tracks. Okay, I will explain it here. You can take tracks like this also. Okay, just make sure that you understand clearly. Component middle space or the bottom space of every component can be used for taking your tracks. Okay, you have the circuit of a simple fire alarm. Okay, yesterday you sorry, day before yesterday you have saved the circuits. Okay, just go through that and observe if there are any mistakes in my design. Okay guys, my PCB routing is completed. Okay, for a simple fire alarm circuit. Okay, can anyone find any mistakes in this circuit? Okay, if you have any doubts related to this circuit, you can ask me. Okay, now I am giving the board area to this circuit. Okay, after that giving the copper area. After that giving some labels. Okay. Okay, now if you change it to real world, you can observe the real world diagram of your circuit. Okay, is the process clear for everyone? PCB layout designing. Okay, I have given you a task, and whoever attends the class and does the work, okay, will get the certificate. Okay, whoever not attending the class, there is no chance for them to get the certificate. Okay, attendance is compulsory for getting the certificates. If you have any doubts, you can ask in WhatsApp also. Okay, I asked a question. Do you have any doubts in this circuit, PCB designing? Okay, thank you. And if you observe the artwork of this circuit, it will be looking like this. Okay, while taking out the printout from your designing software, always you should take the real world or normal diagram also. Okay, or else you may get confused to place the components in artwork. Okay, suppose if you directly take the printout of artwork and try to place the components, you may place capacitor instead of resistor and resistor instead of capacitor. Okay, so that your circuit will not work properly. Okay, that is the reason while taking the printout, you should always take the printout of artwork along with your normal diagram or real world diagram. Okay, if you observe them, you can be able to place the components correctly. Okay, is it clear for everyone? Tomorrow we will be dealing the circuits related to ICs. Okay. Okay, Mr. Srinivas, we cannot feed this directly to a machine. Okay. In industries, they use different process. Okay. We cannot directly feed it. We need to take the printout. If it is an industry, once the designing engineer completes the PCB layout, he then sends the layout to verification, and after that verification the circuit will be printed on to the boards. Okay, suppose if you want to, okay, in advanced softwares you will get introduction about how to send your layouts to a manufacturing company. Okay, that is also there in your training. Okay, in easy EDA you can be able to email your PCB layout design to some of the manufacturing companies. Okay, if you are required of more than 10 to 20 PCBs of your layout design, then they will provide the PCBs. Okay, PCB boards for your layout. Okay, that is another topic. We will discuss it in the further classes. Okay, but we cannot directly feed now. Okay, in case if we are manually designing PCB boards, then we can directly take the printout of this from a laser printer. Okay, we can directly export the file or we can directly take the printout of the file. Okay, is it clear, Mr. Srinivas? Mr. Srinivas. Okay, guys, if you have any doubts, you can ask in WhatsApp group also. Okay, that's it for today. Tomorrow we'll meet at 4 p.m. Okay, thank you everyone. If you have no queries, you can leave the session.